Hello, I'm Seema and welcome to part 2 of the chapter Chemical Bonding and Molecular Structure. In the previous video, I discussed the Corson-Lewis approach towards chemical bonding and the modification made by Langmuir. In this video, I will tell you how to write the Lewis structures. Let us come to it straight. There are 5 steps that you have to keep in mind when you are making the Lewis structure of a compound or a molecule, which may be the molecule of an element. What are these steps? The first step is that once you have the formula of the compound or the molecule, you should count the total number of valence electrons that are there in the entire molecule. That is, you have to find the sum of the valence electrons of all the atoms that are involved in the molecule, that are present in the molecule. For example, if you have methane, methane is CH4. Carbon has 4 electrons in its outermost shell, that is 4 valence electrons, and hydrogen, each hydrogen has 1 valence electron. So there are 4 valence electrons contributed by the 4 hydrogens and 4 valence electrons of carbon, which brings the total to 8. The second step is, once you've written down, once you know the total number of valence electrons that you have to deal with, the next step would be that if the species given to you is an anion means it is negatively charged, and negative charge is due to addition of electrons. So if there is a single negative charge, add 1 electron to this sum. If there are 2 negative charges, add 2 electrons. So you have to add the number of electrons that is equal to the number of charges on that species. For example, if you have CO3 negative, CO3 negative means CO3, oxygen has 6 valence electrons, carbon has 4 valence electrons, there are 3 oxygens, so 6 into 3 plus 4 is 22, and there is a 2 negative charge on the carbonate ion. Therefore, this 2 negative charge means there are 2 electrons more in addition to the valence electrons that are present, which were 22. So the sum comes out to be 22 plus 2, which is 24. If the ion is a cation means it is positively charged. And a positive charge is possible when electrons have left a species. It can be an atom, it can be a group of atoms, an ion or a molecule, whatever. So a cation, if it is a cation, you have to subtract the same number of electrons as is the number of positive charges on the ion. For example, ammonium ion is NH4 positive. So ammonium has 9 N, nitrogen has 5 electrons, 4 hydrogens, each contributing 1 valence electron. So 5 plus 4 is 9. And since there is a positive charge, a single positive charge would mean removal of 1 electron. So ammonium ion would have 9 minus 1, which is equal to 8 valence electrons that you have to deal with. So we must first know what is the number of electrons that we are dealing with. After this, we now are aware of the number of electrons that we have to distribute in the entire structure. So the next step, that is, that you have to look at the formula that is given to you, and you have to see and you have to guess how would the structure be. Generally, you would see there would be a central atom in the molecule and there would be other atoms that would be surrounding this central atom. So the number would give you an idea. This is 1 and these are 4. So obviously that 1 should be somewhere in the center and the 4 should be surrounding it, right? 1 is just a little idea you get by looking at the formula. So you have to guess the structure of the molecule and you distribute the electrons and you start distributing these electrons, the total electrons, among all the atoms, and they should be either as lone pairs or bond pairs. Basically, you make 1-1 bond each in the beginning and then we find what is left. I'll come to that later. So you have to think a little and then assign pairs of electrons as lone pairs or bond pairs. When we do an example here, this will be clear to you. The next step then is that generally the least electropositive element is usually in the middle. I told you the one which is present in lesser number is usually in the middle, and that usually is the electropositive element. And the electronegative element is normally the one that is surrounding, not in methane. Hydrogen is more electropositive in comparison to carbon. But yet, in this case, see, carbonate ion, carbon is more electropositive. So it is carbon which is in the center. In ammonium, nitrogen and hydrogen. So hydrogen is more electropositive. Anyway, but generally it is the least electronegative or the most electropositive element would be in the center. Yeah, if you have NF3, fluorine is more electronegative than nitrogen. So nitrogen is least electronegative or more electropositive. So the electropositive element is usually in the middle. This, you know, with compounds where there is hydrogen, hydrogen usually is the more electropositive element, but that does not make it the central atom. The reason being that hydrogen has a combining capacity of only one electron. It can only form one bond, and you cannot be the central atom holding so many other atoms around you if you have a capacity of forming only one bond, right? So this factor is not so visible in compounds that have hydrogen in them. But usually the more electropositive element would occupy the center of the molecule. This is not a rule, but generally this is found. Then the last step is that after you've made the layout of the molecule, okay, the molecule should look like this, then you start making single bonds between the molecules, and after making the single bonds, you now assess the situation. How many electrons are required by which element in order to, or which atom in order to complete its octet. And how can you do that? For that you may have to make multiple bonds somewhere. You may have to make that is, multiple bonds means a double covalent or a triple covalent, and sometimes you even have to form coordinate bonds. A covalent bond is usually formed by the contribution of two atoms, one electron given by one electron given by the other. There's an overlap, there's a sharing of electrons, and both the atoms possess that electron now. Both the atoms belong to both these, both the electrons belong to both these atoms, thereby making completing the octet. But sometimes one of the atoms contributes a lone pair of electrons towards bonding, and such a bond is known as a coordinate bond. As we do our examples, we will observe some of these coordinate bonds also. So let us start finding out or making the Lewis structures of these molecules. I've chosen these few examples, and I hope by the end of solving all these, making Lewis structures should be an easy task for you. Okay, the first one is H2, hydrogen molecule. So let's make the two atoms, hydrogen and hydrogen. Both the hydrogens have one electron each, right? If they have one electron each, what should the structure be like? Hydrogen, there should be a single bond between the two hydrogens, right? So the Lewis structure would show you a single bond between the two hydrogens, and this pair of electrons, one contributed by one hydrogen and one contributed by the other hydrogen, means there's a single covalent bond. The next molecule is O2. O2. So you have two oxygen atoms, one oxygen, one oxygen. So what is the first step? Find out the total number of valence electrons. So both the oxygens have 6 electrons each. And you know what, when I said that you have to guess the structure, you need to use a little intelligent guessing. Oxygen has 6 electrons. In order to complete its octet, what does it have to do? How many electrons does it need? 2. If it needs 2 electrons, it means oxygen will form 2 bonds. In order to get these 2 electrons, oxygen will form 2 bonds. So how would you draw the Lewis structures? You will draw the Lewis structures in such a way that 2 electrons to form 2 bonds should fall between the 2 atoms, right? So these are the 2 oxygens, and the overlap, if you really look, we usually do not make the circles, but I'll do it for you to understand this, that if this is so, you'll have the 2 pairs of electrons, they should be towards each other, so that you can show that between the 2 oxygen atoms there's one single bond, and then after a single bond has been formed, the octet is not complete. Now this has 6 plus 1, 7. This also has 6 plus 1, 7. Obviously there should be one more bond. So O2 molecule will have OO double bond, and this would be the Lewis structure. So in the Lewis structure, you need not make the lines. It will be understood that these two electrons are the shared pair. You need not even make the circles, right? Just the electron dot structures are enough. So the next molecule is C2H4. C2H4. So we'll say hydrogen makes single bonds. So hydrogen usually is on the ends. And the two carbons, they should form the center. Right? So how would they form the center? I have carbon and I have carbon. Each carbon has 4 valence electrons. Right? So there would be 4 valence electrons on carbon. So I'll make one. I'll make, if each has 4, carbon should form 4 bonds. Right? It can, and we have 4 hydrogens. So we give 2 hydrogens to this carbon and 2 hydrogens to this carbon. Okay? It's just again guessing. We are guessing that there are 2 carbons and 4 hydrogens. So one carbon should have 2 hydrogens, one carbon should have 2 hydrogens. Right? Now every hydrogen has 1 electron and every carbon has 4 electrons. Every carbon has 4 electrons and every hydrogen has 1 electron. So let us make the 4 electrons of carbon and let us try to make them facing these hydrogens and the other atom. So we'll have 1, 2, 3, 4. That is 2 electrons of carbon I have made here and 2 electrons of carbon I have made here. Now carbon has 4 electrons and it needs to form 4 bonds in order to complete its octet. So what will I do? I'll draw the next 2 electrons here. Now each carbon requires to form 4 bonds because it has 4 electrons and it needs 4 more electrons to complete its octet. Hence carbon should form 4 bonds and every hydrogen has 1 electron. It needs 1 more electron to complete its duplet. So I have positioned them in such a way that every hydrogen forms 1 bond with every carbon, with both the carbons, 1 bond here, 1 bond here. So all the 4 hydrogens have their duplet completed. We are now left with carbon. Carbon should form 4 bonds. 2 it has formed with these 2 hydrogens. Let us take this carbon. It has formed 2 bonds with the 2 hydrogens. So now carbon has 4 electrons plus 2 electrons of hydrogen, which makes it 6 electrons. Carbon still needs 2 electrons. So in order to get those 2 electrons, it should form 2 more bonds. And that it does with this. The situation is the same with this carbon. It has 4 plus 2, that is 6 electrons. It needs 2 more. It's easy. Both the carbons should form a double bond here. So the structure of ethene molecule would be like this. If you remove the lines, that would be the Lewis dot structure. That is carbon with 2 bonds with carbon, a bond with hydrogen here, a bond with hydrogen here, a bond with hydrogen here, and a bond with hydrogen here. Right? So this is how you'll make a molecule of ethene. Let us now come to the next example. After ethene, we have ethyne. So let's make ethyne now. Ethyne is C2H2. Now, there are, again, similar to this, there are 2 carbons and I'll place the 2 carbons like this, and now we have only 1 hydrogen. So we make the 2 hydrogens on both the sides. We give each carbon 1 hydrogen, and this is the more electropositive element, rather actually hydrogen is, but since hydrogen is always on the ends, therefore carbon will be in the middle. Now, carbon has to form 4 bonds while hydrogen has to form 1. We first make the 1 bond between carbon and hydrogen. So which means I've given carbon 1 electron. We are now left with 3 more electrons, and carbon has to bond with all the 3 electrons because it needs 3 more. 3 plus 1, 4. 4 plus 1 with hydrogen makes it only 5. It needs 3 more electrons to complete the octet. So it should form 3 bonds. So what should I do? I should place the 3 electrons between the 2 carbon symbols. And when I do that, now it's understood that the carbon, it forms a bond with hydrogen like this. This carbon also forms a bond with hydrogen like this, but it forms 3 bonds with the other carbon. So the ethyl molecule, it has one bond between the carbon and hydrogens and a triple covalent bond between the two carbon atoms, thus completing the octet of the two carbons and the duplet of the hydrogens. You are basically keeping all these points in mind, right? But since we have not yet come to a compound that has a charge, we have not gone to the charged cation and anion part. So let us now come to the next compound that we will find the structure for. The next compound after ethyne is ozone, O3. Now there are 3 oxygen atoms. So oxygen has how many valence electrons? 6. So 6 3s are 18. Ozone is a neutral molecule. I'm just trying to follow these steps to make it clear that we do keep these steps in mind. So there are 3, there are 18 electrons, and the 18 electrons are around the 3 oxygen atoms. There will be no, since all of them are identical, one of these will be in the middle and the other 2 will be on the sides. And then we'll try and see how the electrons are to be adjusted. It's neutral, so we do not have to add or subtract any electrons. So let us have oxygen here, an oxygen here, and an oxygen here. Each oxygen has 6 electrons. So let us first make the 1, 2, 3, 4, 5, 6. Similarly, this one has 1, 2, 3, 4, 5, 6 electrons. Okay, 1, 2, 3, 4. I'm not positioning them correctly yet. Now, every oxygen needs 2 electrons to complete its octet. So the first thing that we do is that in order to form one oxygen should combine with the other oxygen to form 2 bonds. So let us say that these 2 have formed a bond, a double bond, right? If these 2 have formed a double bond, then it means that 6 plus 2, 8, 6 plus 2, 8. The octet of these 2 oxygens is completed, but this oxygen is just lying out there. It has not bonded with any. So this is not right. What should we do? We should first make one bond between all the atoms, join them together to form a molecule, because that's how they exist in nature. So we would first join them to make one bond. Right? If we join them to make one bond, then one bond here and one bond here, right? Now this oxygen has 1, 2, 3, 4, 5. So it had 6 electrons of its own, and it was supposed to form 2 bonds, which it did. It has formed a bond here and a bond here, which is completed. So one guess would be that ozone should have a bonding here now. If every oxygen should form 2 bonds, one bond between this oxygen and this oxygen should complete the structure of ozone. Just take a look. Now, this oxygen forms 2 bonds, so it has 6 plus 2 makes it 8 electrons. This has 6 plus 2 makes it 8 electrons. 6 of its own plus 2 here and here. So each one has the octet completed. So one of the structures of ozone is that this is how it should be present. But our knowledge of coordinate bonds shows us that this is not actually so. The actual structure of ozone is that ozone has the 3 oxygens here. One of the oxygens forms a double bond with one oxygen. So you have one pair is used up here to form a double bond. It's now left with 4 electrons. This is also left with 4 electrons. And this has 6 electrons. Right? So what happens as a double bond is present between these 2 oxygens, here this oxygen uses a lone pair, this lone pair, and it forms a bond with this oxygen with that lone pair. It forms a bond using these 2 electrons. And when it uses, so let me make these 2 electrons here. So when it uses these 2 electrons to form the bond, the electron belongs to this oxygen, but it has moved towards this oxygen. And it is shared equally by the 2 oxygens, this oxygen acquires a negative charge. And because it has attracted electrons of this oxygen, and this electrons has kind of pushed one of its electrons away and actually given a pair of its electrons to do the bonding. And such a bond is known as a coordinate bond, where the contribution of the electrons is not done by both the atoms, but one atom contributes the pair of electrons, and that atom that contributes the pair of electrons acquires a positive charge. So the actual structure of ozone with later study was found to be this. We are not going into the details how the structure was found out. We're just learning that some of the structures are known to us, and we try to justify or distribute the electrons using Lewis structures in order to understand what the arrangement might have been like. So sometimes this is what our thinking would tell us, but the actual structure of ozone molecule is like this. So after ozone, the next molecule we have is NF3. NF3. Now, out of these, nitrogen is more electropositive than fluorine. So nitrogen should form the central atom. So I'll make nitrogen in the center, and it would have the 3 fluorines. So nitrogen has 5 electrons, 1, 2, 3, 4, 5. And the 3 fluorines, fluorine has 7 electrons. Each fluorine needs to form 1 bond. So we'll make that 1 electron that is not paired towards the central atom. So fluorine has 7 electrons, 1, 2, 3, 4, 5, 6, and the 1 electron which has to be bonding, I put it on the side of nitrogen. The third fluorine is here, 1, 2, 3, 4, 5, 6, and this is the 7th electron. So this would be the structure of NF3, where 1 bond would be formed by every fluorine with nitrogen. And nitrogen would be left with 1 lone pair of electrons. Every fluorine, after forming 1 bond, has 3 lone pairs of electrons, but it had 7 electrons of its own. It made a bond and got 8 electrons. This had 5 electrons of its own, made 3 bonds, 5 plus 3, 8, and every fluorine has 7 plus 1, 8. 7 plus 1, 8. So the octet of all the atoms is completed. So that was NF3. Let us now make the Lewis structure of this carbonate ion. The carbonate ion, let us first see, I'm now trying to follow these steps to make it clear that how we use these steps in all the examples, but just elaborating it here. Carbon has 4 valence electrons, plus oxygen has 6 valence electrons, and there are 3 oxygens, so 3 into 6. And the negative charge is 2, so you will add 2 more electrons to this. So the total comes to 24. There are 24 electrons that have to be put. Now out of these, carbon is more electropositive, so that becomes the central atom. So I put carbon here, and I write the 3 oxygens on all the 3 sides. 1, 2, and 3. Since it is an ion, I put the entire structure inside a bracket, and I put the charge to negative. So now I have 24 electrons, and I have to adjust them here. So first of all, we put a pair of electrons between oxygen and carbon, between oxygen and carbon, between oxygen and carbon, to make that single bond, or to make the atoms bonded to the central atom. After this, we have now, how many have we made? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Let us put here 8 electrons here, the carbons. Let me put 2 electrons here and 2 electrons here. 2 and 23, 24. If you look at this now, every oxygen has 8 electrons. If you see, these are 8 electrons each. But carbon, how many does it have? 2 plus 2 plus 2. If you imagine these to be bonded, it has only 6 electrons. If it has only 6 electrons, it means these are bond pairs. So this is a single bond here between this carbon and this oxygen. This one is a single bond here, a pair of electrons here. This is a single bond here, a pair of electrons here, and this is a single bond here, a pair of electrons here. So we have 8, 8, 8, but only 6 around carbon. So what should we do? This one also has 8, this also has, oxygens are satisfied, only carbon is not. If I just move one pair of electrons here and I make a bond here with that pair of electrons, if this oxygen shares these 2 electrons here, then it forms a carbonate ion. Now carbon also has 8 and oxygen already had 8, it only contributed this pair here, so it still has 8 and every oxygen also has 8 electrons. So the octet is completed for all the atoms, and this should be the best Lewis structure for carbonate ion. So this is how you make the structures for ions. Let us now make the structure of HNO3. So HNO3 is the molecule, and this also, just like the carbonate ion, has 24 electrons. Right? So let us make the structure. Hydrogen is the terminal atom. We'll imagine this to be an NO3 negative ion, and we'll make the structure. N being more electropositive should be in the center. N, O, O and O. And with one of the oxygens, we add a hydrogen here. Right? So let us make a pair of electrons to show the bond pair. There should be one bond here, one bond here, one bond here and one bond here. That is, we are first connecting with one bond, we are connecting the central atoms. All atoms to the central atom. And now we have to complete the 24. So how many do we have? We have to complete 8 for each. So this would be 1, 2 here, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? Now for every oxygen there are 8 electrons. For hydrogen there are 2 electrons. That's what it needs. And let's count the total number of electrons. 8, 8 plus 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We do have all the 24 electrons. Now the problem here is that every oxygen has 8 electrons. This has 8. Do you see here? 8. This has 8. Here. Hydrogen has 2. And this oxygen also has 8 electrons. The problem is with nitrogen, just like the carbonate ion, it now has only 6 electrons. So in order to complete that, those 6 electrons to complete its octet, one of the oxygens, what will it do? It will move its electrons here and make a double bond with nitrogen. So when the double bond is formed, I'll draw these like this now, this pair, so that you feel this is a single bond here. Again, this I can draw it like this to show you the single bond here. So this would be the and between the 2 oxygen and hydrogen. This is the single bond here. So this would be the structure of HNO3. So what happened? There was all the octets are now completed. Oxygen had 8, it still has 8. Nitrogen had 6, but by forming a double bond with this oxygen, it now has 8 electrons. So the octets are completed, and this should be the structure of HNO3. Let us now write the structure of carbon monoxide, CO. What is the total number of electrons? Carbon brings 4 electrons and oxygen 6. So we now have a total of 10 electrons. So carbon being less electronegative, we consider it to be the central atom, although there are only 2 atoms, carbon and oxygen. And let's make a bond between the 2. So a bond means there are 2 electrons. And we now have a total of 10 electrons. So let us fill up oxygen. 2, 3, 4, 5, 6, 7, 8. 8 of oxygen filled up, and 9, 10. So we have oxygen has its octet completed here, but carbon has only 4 electrons, if you see. Do you see here? Carbon now has only 4 electrons. It needs how many? 2 more. It needs 4 more electrons to complete its octet. So what is done? One of these pairs here moves from here and comes between carbon and oxygen. So we have one of these coming here to make a double bond, and still carbon has only 6. So one of these pairs also moves here to form a triple bond. So carbon monoxide would have a structure like this. It would have carbon with oxygen in a triple bond. So that was carbon monoxide. Let us now come to the next ion, that is NO2 negative. Right? So nitrogen would be the central atom, N, one oxygen here and one oxygen here. What's the total number of electrons we are bringing here? It is, nitrogen is 5 and oxygen is 6 into 2, that's 12. And you have to add one electron because there's a negative charge. So this would be 12, 13 plus 5 would be 18. So 18 electrons. So let us first make a single bond between the two. So 1, 2, 3, 4 electrons gone, right? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Right? We've made the 18 electrons. Now, the 8 electrons of this oxygen are completed. 8 of this octet of this oxygen is also completed. But what about nitrogen? Nitrogen has only 6. When nitrogen has only 6, one of these oxygens is going to contribute, move its electrons towards nitrogen and form a double bond. Right? So this would be the structure, and since it's an ion, you'll put the entire structure in a bracket and put the negative charge on it. It would have a single negative charge. So that would be NO2 negative. Let us now come to the next structure, that is methane. Methane has carbon in the center because hydrogens always come to the end. Carbon CH4, 4 electrons, and hydrogen 1 into 4 is 4, so we have 8 electrons in all. Carbon in the center, and we put hydrogens on the 4 sides. It's one of the simplest Lewis structures to make. 1, 2, 3, 4, 5, 6, 7, 8. One pair each to connect to the central atom. One bond here, one bond here, one bond here, one bond here. So the total number of electrons required was 8, and we've already made 8. So each hydrogen completes its duplet by making a single bond with carbon, and carbon had 4 of its own electrons, 4 bonds with the 4 hydrogens, so octet completed. So that's the structure of methane. And now we come to the last structure that I had planned for today, and that is NH4 positive, the ammonium ion, NH4 positive. Now nitrogen has 5 electrons. The 4 hydrogens are 4 into 1, that is 4 electrons, and since it has a positive charge, you remove 1 electron from this, right? So we have 5 plus 4 minus 1 is 3, 5 plus 3 is 8, so we have 8 electrons. So nitrogen would be the central atom because hydrogen always occupies the sides, so we'll have hydrogen here, 1, 2, 3 and 4. We'll make the 4 bonds because that's how they get connected to the central atom. And we need 8 electrons, so 4 on hydrogen. Each hydrogen can have only 1 electron, so they already have that 1 electron and they're forming the bond with nitrogen. 1, 2, 3, 4. And nitrogen now has 8 electrons already. And 8 electrons is what we needed. And the entire charge on the ion would be positive. Right? Ammonium ion, it had 8 electrons, so that's how. Nitrogen basically has 5 electrons, but it has used the electrons, and there's 1 positive charge, which means one of the electrons is lost. So now it has 4 electrons, it forms 4 bonds with the 4 hydrogens. So that is how we just basically are following these rules. We first find out the sum of the total number of electrons that are present. Then after finding out the sum, if it's the anion, we add the number of electrons to the total sum. If it's a cation, we subtract those number of electrons from the total sum. Then we find out the electropositive atom and we make it the central atom. Make 1 bond with all the other atoms to the central atom. And then the remaining electrons are filled up first on the outer atoms to complete the octets, and then check the central atom. If its octet is not completed, shift electrons towards that. And if it is completed, then we have our structure ready. So this is how you make the Lewis structures. With a little practice, you will only get better, and practice as much as you can. And if the video helped you, please give it a thumbs up, subscribe to my channel, recommend it to all your friends, and keep returning for more videos in chemistry. Thank you. and bye-bye.